How you going, guys? Curtis from Cutting Edge Engineering. Today's job we have two D11 blade lift barrels in for repair. These barrels are off a D11 Dozer and it is Caterpillar's biggest bulldozer they manufacture. And what these do, these lift and lower the blade while the machine is in operation. And if you remember from last week's video where we repaired the yokes attach onto these cylinders. So if you can imagine the barrel standing vertically on the dozer, the forks of the yoke go underneath the trunnion mount. There are two caps that then go over the trunnion mounts and get bolted onto the yoke. They're not off the same machine, but they do belong to the same customer. So these aren't in to be rebarreled, these are in to have their trunnion mounts repaired. These mounts are always going to wear out because it is metal on metal contact. You can fit grease nipples to these joints in order to aid with lubrication, but it's just the nature of the way things work and what the machine is doing, they are going to wear out. So there are bearings that then get fitted onto the trunnion mounts. They are a sacrificial piece of material that is supposed to wear out, but over time the trunnion mounts do shrink in size because of the constant hammering, and the bearings just don't fit anymore, they end up falling off. And that's what's happened here, but these went a little bit further than they were supposed to, and they are quite worn out. And something I did notice, these have actually been repaired before, and the reason I can tell that is there is centers in the end of the trunnion mounts. That is not a factory thing, that is done from someone doing the exact same repair we're about to do. Trying to set up off a surface that isn't round anymore or you've just welded can be quite difficult. So putting a center in each end of the trunnion mounts, it's really going to help with setup, and it's also going to help for the next guy that has to repair them. So you may have seen in a previous video where we've done trunnion mount repairs before, and that was because we were doing a complete cylinder rebuild. So the cylinder was completely disassembled and we were able to spin the trunnion in the lathe between centers. But in this case, because it's still attached to the barrel, we can't do that. So ideally you would set these up in a machine like a horizontal borer where you can access both sides after turning around the table. I don't have a horizontal borer yet, and I cannot use the kitchen and walker because it is still a work in progress. So we're just going to have to do these in our milling machine. So we're going to be using our shop-made V-blocks that have a key in the bottom of those so they locate into the table. I will then use an edge finder to find the center of the V-blocks, which will save me trying to find the center of the barrel. Because of the shape of the trunnion and how tall everything is, I am going to have to use 1, 2, 3 blocks in order to pack the barrel off the V-blocks so the trunnion is not sitting on the table. And because they are all machine surfaces, the barrel will automatically find the center of the V-blocks. If you're wondering why I don't have a V-block set up on each side of the trunnion mount, that is because this side of the cylinder tube is actually a larger diameter than that side. So the bottom end is machined down for the trunnion to slip over it when it is manufactured. They do not machine the top side, so it is slightly bigger in diameter. And if I was to have a V-block on this side, the barrel would essentially be sitting a little bit on the piss. So now I'm just going to use an alignment center in order to pick up on the center point that has been drilled into the end of the trunnion. And that's just how easy it is to get a barrel in the center line of the machine when the trunnion mount has that center hole drilled into it. Now that's in alignment, we're going to tighten up the clamp so nothing can move. The tool we're going to be using is our adjustable boring head. It does have the external part of it so we can go on the outside of a job. And the insert we're going to be using is a CCGT. So I know that does look a little bit shot made. I did have to cut and turn the end of the tool holder because I didn't have the right one for another job, and it just happens to work out perfectly for this one too. A bit more off. Right, so that cleaned up. I ended up removing about 1 mil off the outer diameter, but there's not quite enough material being removed in order to put a substantial thickness of a weld layer there. So I am going to reduce it just a little bit more so the weld layer will end up a little bit thicker. So yes, you could just weld this up and machine it back to spec, but in my opinion, that is cutting a corner. I prefer to machine down that surface so everything is nice and round again, and I remove all of that dirty material, and then I put a fresh layer of weld material there before machining it back to spec. That way you have one material around the entire diameter and you don't run into hard spots, or you don't have a mix matching materials and their tensile strength. So that's why I do it this way. Right, so I've got the OD turned to size. Before I flip it over, I am going to fix up the hole that's been drilled into the end of the trunnion mount, because whoever did it before me did not use a center drill, he just used a jobber drill. Using a center drill, it's much easier to get them in alignment, so we'll clean that up and then we can turn it over. So I'm about to flip this. It's going to be really easy to set it up because I do have center holes in the end of my trunnions. If you don't have center holes, there are other ways you can do it. One of those methods is using the bolt holes on the head flange and a level. Screw the 2 bolts into the head flange, sit a level across the top of it, take the reading on what it is. You also use a tape measure from the head flange back to the center point of your tool. And when you flip it over, as long as you get the measurements matching up and the level matching up, it's going to be good. Another repair option would be you could machine the mounts down undersized, machine up a custom sleeve to then take the place of the original bearing, but that's not how I like to do things. I like to put all components back to an OEM specification That way, if anyone is to purchase this machine later on or another repair needs to be done, they can simply purchase OEM parts off the shelf and don't have to worry about getting anything custom made or modified to get their machine back to work. Righto guys, so that is the other side machined. It didn't fully clean up because there was a fair bit of wear in that particular area. So rather than cut the entire diameter down just to clean that up, I'm gonna grind that area there and I'll just put a little bit of heavy weld in that spot. If I was to machine it down so it cleaned up, that would mean a lot more welding around the entire diameter, and that's just not necessary. So we'll get this out of the machine and get the other one up to the same stage. So that's our second one done. We're going to take them over to our welding area and get them set up for welding. Righto, so there's a couple of ways I can weld these up. I can put them flat on a pallet and weld horizontally across the mount, or I can stand it up on the trunnion mount and then walk around it and weld it up. But this time I want to try something different. So ideally having this in a more vertical position and me standing in front of it would be perfect, but the machine is struggling a little bit to rotate it around because one end is slightly heavier than the other. Rather than break the machine, I'm just going to weld it the way it is. I'm going to use the forklift tine as a steady for my hand to rest on, and I have an extra long handpiece for my MIG welder so I can stand out of the way. This can spin and we'll get a nice even weld build up. So the wire we're going to be using, it is ER70 S6 copper free. We will be backing that up with Argo Shield Universal, which is 80% argon, 10% CO2 and 10% oxygen. We'll be running that at around 20 volts and about 4.7 meters of wire a minute. Righto, so that actually went really well. Although it might have looked uncomfortable, it was actually not too bad. So let's crack on with the rest of it. Righto, so that is our second trunnion fully welded. Using the positioner is definitely a good way of getting consistency in the weld layer. I would imagine doing a D10 or a D9 would be a lot more comfortable and a little bit easier because they are a shorter barrel. So these are far too hot to machine at the moment. We're going to give them a couple of hours to cool down and then we can get them set back up in the mill.
That's fine. Ready?
Who's a good boy?
Come on, come on.
Righto guys, so the welding has cooled down enough. We can get the first barrel set back up in the milling machine and then we can start machining the OD to suit the bearing. So we are aiming for a 0.1 interference fit. Our finish size is going to be 88.53, which will give us our 0.1 crush. So I'm going to take a roughing cut so I can get a measurement so we can then determine how much I need to remove to suit the bearing. Righto, so after our first roughing cut, we landed at 93.8 mil, so we've still got about 5 mil to come off. Because the tool is hanging so far out of the boring head, I'm going to take each pass at 0.5 mil depth of cut, which is 1 mil overall. If I tried to go any more, I would probably end up breaking an insert and getting too much chatter. So I'm about to do my final cut, but before I go and adjust the boring head to the final dimension, I am going to take a spring pass. Because the tool is hanging out so far, it can cause tool deflection. So rather than overcut it or undercut it, I'm just going to take a spring pass at its last dimension. I will run it down the job a little bit to clean up the surface, then I can take my measurement and adjust it from there. Our current measurement is 88.72. We do need to remove about 0.15 of a mil in order to bring it to the crush size for our bush. Righto, so our final dimension come out spot on. I'm really happy with that. What I'm going to do now is change out the tool so I can put a chamfer on the top edge, which will act as a lead for the bearing to be fitted onto the trunnion mount. And then I'm going to flip it over and get the other side up to the same stage. Righto guys, so that is the machining completed on our first barrel. I still need to clean up the radius in the bottom corner of the trunnion mount, but I can't do that with the milling machine. I don't have the right tooling, so I will end up doing that with a polycurve wheel on a grinder. So let's get this one out of the machine, get the second one set up. And I've gone ahead and completed the machining on the second barrel as well. With all of that done, I can now grind up the barrels and install the bearings. Because we can't shrink down the trunnion mounts with liquid nitrogen, we do need to expand the bearing in order to get them to fit. So using an oven is a nice controlled way to get an even heat throughout the entire bearing. And while that's heating up, we're going to clean up the bottom radius around the trunnion mounts. We're going to be using a wheel called a polycurve. Sandpaper goes all around the edge of the wheel, and they're really good for cleaning up welds, for handrails, and lots of other things. They're just a very handy wheel for this sort of work. That needs a bit more. Righto, so I've tried that twice and it's just not going onto the trunnion mount, so I'm going to give it a little bit of help using the Oxy and LPG. It's not going to take much to expand it, just that little bit further, so it'll just slip straight on. So that's this one completed. Unfortunately, the customer only supplied us 2 bearings. There is supposed to be 4 in order to do both of the barrels. We don't keep them in stock, so we're just going to grind up the other barrel ready to go, and the customer will fit the bearings themselves. Righto guys, so the job is done. For about a day's work, this has been a very economical solution for our customer, and this repair should last as long as the genuine parts would, providing they keep up with their preventative maintenance and change out these bearings when they do wear out. These components should last the life of the dozer. So that's another job done. Thanks for watching. Right, you ready?
Yeah.
Ready?
Yep.
You ready?
Sure.
Ready?
Yeah, just and.
And what? Wait, how am I starting that? Wait, what did you start that? Oh, fuck me. Fuck, where'd I go with that? What the fuck did I call that? Like the train fuck off? It's fucked off. But in my opinion, that is a half-assed job. That is cutting a corner. I'll put a bit of a heavier weld layer there, and then I'll put a bit of a... pit. What?
Hang on, that got confusing.
So...
I need 10 years to edit this.
I was gonna say it all again.
Okay.
Ready?
Yeah.
Fuck. Yeah, that was it. Size matters.
Jesus. What the hell? It's not on there. Looks like a face. Just looking for this. What colour? How long? So you mean this one?
Can you see? Oh.